All right. So let me start with the end. So this is the HotdocX platform. So this is Coq running in the platform. So it's interactive, and the code is right here, and you can change it. All this is generated by AI. So that's the bottom line of it. All right. Now I will go maybe bring some context to it. I will start maybe with an experimentation. So it seems like it's a different topic, but it's actually the same topic. It's about Coq and about how do you experiment with new ideas. How can you like try new things? So I start with the problem. So this problem needs to be addressed because this project about M-Dash, it started actually with Coq code, right? So Coq code, I tried to experiment. I saw that maybe it doesn't work as I want. And then I moved to LambdaPy, which is another proof assistant, which allows to prototype some computer science or mathematics experiment. So I saw that it doesn't work really as I want. And then I went from scratch, tried to build this system from scratch. So this is all related. It looks like it's not related, but it's all related. It's part of a story. Okay, I need to tell you first the part one, the origin. Why? I think at the end it will be good if we have maybe many versions of Coq, where maybe we can disable some checks, we can permit like any kind of crazy thing just to experiment. We can even if it's inconsistent or any kind of we really need maybe also maybe a simple version of Coq, maybe Coq Lite, maybe so that it's maybe less features, but maybe it's easier to teach, to experiment, to try new things. So this is all the motivations for what's coming. So, but I really need to go through this. It might look like it's not related, but it's all part of the motivation, the story all behind that. So what is M-Dash? So it's like a dependent type data logical framework for computational synthetic category theory. So what is that? Well, it just says that on the slides. And the basics of the mathematical basis of this is that we want like categories, functors, like in mathematics, to not just be encoded, but to be primitive building blocks of the formal language. And so things needs to compute. Things need to is not just encoded like. So that's the proof become computations. So so we need M-Dash is a framework with those properties. So we have maybe like notions like category, context functors, and then some coherence which are checked definitionally. And this is implemented in TypeScript. So this can run in the browser, right? And is formally specified by LambdaPy. Actually, it could be just a patch. I could just patch LambdaPy. So I could go to the source code of LambdaPy and just apply a patch. But actually, for the purpose of the second part of the talk, actually, it's better maybe to re-implement LambdaPy. You could understand M-Dash like a pod, a re-implementation of LambdaPy, but so design it so that so that it run in the browser, TypeScript, and so that maybe we can have this community monetization and so is a patch of LambdaPy will not be enough. So so it's like a LambdaPy calculus. It has higher order abstract syntax binders, bidirectional type checking, unification hosts, like all these properties. So the user can add their own rewrite rules, unification hints. So that's what I mean by it will be good if maybe Coq, we could just allow all this regardless of if it's not sound or regardless of if there are bugs, but just to experiment quickly. I think in principle, it should not be difficult to do it. I mean, you might need justification, like it might be unsound, but in principle, it should be easy to maybe have some forks, some mini versions of Coq where this is possible. So just explain a little bit functorial elaboration, how functoriality compute. Okay, I think if you just understand this, this here, that here you have composition. On the right side is bigger, on the left side is smaller. Okay, so there's some computation, so there's some progression. Okay, so this is for functoriality, but it works for everything else, naturality, omega categories. Like this can get very complex, but it's always the same principle. And so this use just Costa dozen techniques. Is like, so you normalize and you verify. So I just try, so this specified in Lambda Pi, this is a Lambda Pi specification. It has all these extensionality properties that you can like declare. You can literally declare some univalence like computationally. And so there's some interactive theorem proving, okay, more like a lightweight. And this might be actually more suitable, this kind of for AI assistance. So so we run some tests. We really pass all the tests, the standard test for dependent type system, like inductive type, higher order, and proof sessions. So this is the HotdocX. This is motivated by this, to have this kind of HotdocX system, and where we can have mathematical documents which are executable, verifiable, and in interactive formal content. So the conclusion of M- is like, it's a practical pathway for functorial programming, for synthetic category theory, functorial elaboration, formal specification, and a kernel for the HotdocX platform. But actually, you should really understand this first part as some kind of experiment. Okay, this could be like experiment, any kind of experiment with Coq, all right? Any kind of, or maybe any kind of, maybe a modified version of Coq, like any kind of experiment, because that's the goal. How can we go away from the very strict formal like way that Coq is now, maybe where people can run experiments, share it, like remix it, try different things, maybe use also like the other people to maybe help you, like to crowdsource, like this is the effort so this is the motivation and future work about this. All right, that was the first part. So I took 7 minutes, so I'm going to take another 7 minutes for the second part, and then we have 7 minutes for a discussion. So is there any question already here? All right, so I will continue with the second part. So what is HotdocX and jsCoq? So we want interactive, we want AI-Augmented, and then we want monetizable. So the current state, like we share things with PDFs. So we want a dynamic and accessible platform. So so there were already some initiatives like Coq Exchange to platform docs, right? But I think maybe it's not well articulated what was the problem, what's the goal on those other alternatives. So this is an attempt to maybe articulate it much better. So we want something that's interactive and sustainable, like and it has to motivate people. So it has to involve like maybe again, money. People need to make money or save some time. Make money, it can be mean many things. That could mean cash, or it could mean like for many other things. So we have this marketplace. So it's based on a calendar, and so we go from papers with course to paper as apps. So we can have many templates. Here is a diagram template. This is another M that's running here. And now we add Coqs here. So we add jsCoq, all right? And so this is an interactive Coq session, as I showed you before. All right, so it works until the latest version of jsCoq. Maybe the latest version of jsCoq doesn't really work, because maybe there's some incompatibility. So it will be good if Emilio could fix that or could address the issue. I hope maybe he's here to address that issue. So so this has many applications in education or research. So So what is the business model of this? So this is based for like a trader economy or author economy. So this is what I was talking about, that we could have a Coq light kernel, like a small Coq, or like with maybe some flags disabled to allow like people just to experiment. And so these are the motivations. So we try to articulate here a platform and a sustainable business model. So how will the model work? So one thing that's important here is that when I say HotdocX, this is an open source project, all right? So it doesn't have to be, it can be hosted, like hosted on many pages at the same time. So you can see it as like everyone can become like can become a publisher. Everyone, like you can have like Professor One here has his GitHub and a copy of HotdocX. So all he has to do is just fork the repository, and then this copy of HotdocX will connect to the same back end as the other copy of HotdocX by the publisher too, right? And the Professor One or Publisher Two can just act like as publishers, so they can like onboard new authors, and then there needs to be some kind of economy on that, like some kind of even monetization, like people can actually make money from all of that. And the business model is that maybe Professor One, if it onboards users, he can take a percentage fee on the transactions, and Publisher Two, what the user that he onboards, he take a percentage fee. But the back end is the same back end, all right? So this can be white label, multi-tenant. So I think the success here of this platform is really independent. You should really see it as independent of me in particular, all right? I think this is a model that could work, because this is basically referral, affiliate model, affiliate model. And I think it's distributed. This kind of model is distributed, and the techniques to make this work is a little bit technical, because you have to use like so basically it has to be very, very easy. So somebody just fork the repository, just change the setting, and can connect to the same backend. So everyone can act as a publisher. So we could actually have like the Coq dev team, okay, have their own version of HotdocX. So their own like styling, their own branding, everything, but it works with the same backend, all right? And then so really believe me, so this is and then this is just a demo, okay? This is just a demo. The actual project is not built yet. This is just a demo, so you could contribute here by providing code or sponsor, all right? So that's it here. All right, for the first part. So I think I hope like some people from the Coq team are there in the audience. We can discuss it more. So that's it for now.